All right, I think we're ready to do some examples on hypothesis testing for the mean. But before we do, I know I've said this multiple times, but I think it'll be helpful to have this summary file in front of us because as we go through this problem, we're going to be working through this 5-step process. And we're going to do both the critical value and the p-value approach for these problems. We really only need to do one or the other, but for the sake of practice, we're going to do both. So I would say have this piece of paper and this piece of paper handy just to keep us organized as we work through these problems. Okay, so this problem, heart rate during laughter. Laughter is often called the best medicine. So people wanted to know whether laughter increased the resting heart rate. So this study took place at Vanderbilt University, studying the physiological changes that accompany laughter. So 90 subjects watched film clips designed to evoke laughter, during which they measured everyone's heart rate, beats per minute, with the following results. So X bar, it's a little hard to read. X bar is 73.5. The standard deviation was 6. And it's well known that the mean resting heart rate of adults is 71 beats per minute. Perform a hypothesis test to determine if the laughing heart rate exceeds 71 beats per minute using alpha 0.05. So the first thing I do is just write down the information we were provided. So let's go piece by piece. So first off, we have 90 subjects. Okay. N is 90. We were told that the average X bar is 73.5. X bar 73.5, and that the standard deviation was 6. Okay, so S is 6. It is well known that the mean resting heart rate of adults is 71 beats per minute. Perform a hypothesis test to determine if the laughing heart rate exceeds 71 beats per minute. Okay, so I'll note that here mu naught is equal to 71 because that is the hypothesized value. We were told that alpha is equal to 0.05. All right, and we're ready to get going. So let's start with our hypotheses. We know we have to start with a null and alternative. So recall the alternative hypothesis is the research question. So what is being asked here? Perform a hypothesis test to determine if the laughing heart rate exceeds 71 beats per minute. So it exceeds 71. So I'm going to say mu greater than 71 because the question is asking whether the heart rate exceeds 71. So that's a greater than question. So mu is greater than 71, which means our null hypothesis, the complement of that, will be mu less than or equal to 71. Okay, so let's note that this is going to be a one-sided test. It's one-sided because we have a greater than symbol. Okay, 2, we calculate our test statistic. So let's recall t-stat is equal to x bar minus mu naught divided by s over root n. Okay, so we have all of these ingredients, so let's just plug them in. So x bar is 73.5. Subtract the mean, which is, or the hypothesized mean, which is 71 in this case. Divide by the standard deviation, which was 6. And then divide that by the square root of n, and n here was 90. So let's simplify this a little bit. I have 2.5 in the numerator and 0.63 in the denominator. And so I get a value of 3.97. Okay, now we're ready to establish our rejection region. So we're going to need a critical value of t. Okay, well, recall t is n minus 1 degrees of freedom, so t 90 minus 1 will be 89 degrees of freedom, comma. This is one-sided, so we're just going to use alpha, 0.05. If we look this value up in our table, we will get 1.6622. If you're confused as to how I got this, I would go back to chapter 7 on sampling distributions. We did some examples to show how we get those numbers from the table. Okay, so the rejection region. Recall the rejection region is always going to follow from the alternative hypothesis. So notice this is greater than, which means the rejection region will be greater than a positive value. So that means this will be T stat greater than our critical value of T. So T 89.05. So let's just plug in. That would be T stat greater than 1.6622. So we will reject the null hypothesis if the T stat is greater than 1.6622. Okay, so let's now form our conclusion. So this is where we just plug in. Let's plug T stat into this and see if it holds true. If it does, we reject the null hypothesis. So T stat is equal to 3.97, right? 3.97 from up here is greater than 1.6622, which is our critical value of T 89 point, comma, 0.05. So this is true, right? 3.97 is indeed greater than 1.6622. So that means our T-stat is in fact in the rejection region. And if it's in the rejection region, we reject the null hypothesis. So thus, we reject H naught and accept HA. And then finally, the interpretation. So we're going to restate the conclusion within the context of the problem. So what was this problem? We were seeing whether the laughing heart rate exceeds the resting heart rate of 71 beats per minute. So we will say there is enough evidence to conclude that the mean heart rate during laughter exceeds 71 beats per minute at the alpha equal 0.05 level of significance. Again, we're done. This is the critical value approach. So critical value approach. Okay, but like I said, we want to do both ways. Let's practice the p-value approach. So p-value approach. Okay, actually, steps 1 and 2 are going to be the same. So if we want, we can even just copy them directly from down here. Steps 1 and 2 are the same. All I mean by that is that it's literally just the same thing, what we did for the critical value approach. Okay, step 3. Let's do step 3. which is now calculating the p-value, which is going to be equal to probability that T89 is greater than the absolute value of T stat. So that would be probability of T89 bigger than 3.97. Okay, so with values this big, we're not even going to be able to find these on the table because um, a value of 3.97 is so big, you're not even going to see, like, the table won't include it, which means that whenever you get a value this big, we can just say the p-value is less than 0.001. So if we were to draw this, this is going to be the p-value. But like I said, if you were to look at T89, the biggest value you would probably find is like the value 3, which would give you an area of like 0.001. And so if your number's even bigger than that, that means your p-value is less than 0.001. Okay, so now let's form our conclusion. So our p-value, we'll just call it 0.001, is going to be less than 0.05, which is our alpha. So if p-value is less than alpha, thus we reject H naught and accept H A. And then finally, the interpretation, which is also going to be the same. So if I want, I could just copy this down here again. Yeah, so if I don't want to be lazy and just say same, I can. So we would still say there's enough evidence to conclude that the mean heart rate during laughter exceeds 71 beats per minute at the alpha equal 0.05 level of significance. And so these things should agree with each other every time, and it does, right? We rejected the null hypothesis with both with the p-value approach and with the critical value approach. Okay, let's do another example. Now, if you feel comfortable already giving this a try before seeing me work through it, that's great. If not, let's go ahead and work through another one. Okay, this problem's a little offensive. Birth order and IQ. This is from the class. I go to school down at George Washington University, and this is a question from the textbook. So even though it's kind of offensive, I promise I don't write these questions. So anyway, let's go ahead and just get through this. So basically, there's this idea that people who are at least the sixth born or later in Norway have a lower IQ than the rest of the population. Not sure where that came from, but whatever, let's just go with it. It is known that the mean IQ for all Norway residents is 5.2. In this study, they sampled 581 residents who were sixth born or later. These people had a mean IQ of 4.7 with a standard deviation of 1.8. Is there sufficient evidence to conclude that the mean IQ score for all Norway residents who are the sixth born or later is lower than the country mean of 5.2? Use alpha equal 0.01. Okay, so let's go through this piece by piece, just like we did before. So start with our sample size, n. So a sample of 581 residents. So n is 581. X bar, our average. Okay, so from this sample of 581, the mean IQ score was 4.7. So 4.7. S. So from this sample, the standard deviation was 1.8. So S is 1.8. Alpha was 0.01. Actually, I forgot mu naught. Let's talk about mu naught. Okay, so we want to compare to see whether the mean IQ score from our sample is lower than 5.2, because 5.2 is the average for everyone in the population. So mu naught here is 5.2. Okay, let's start with our hypotheses. Let's start with the alternative, because that is our research question. Is there enough evidence to conclude that the mean IQ score for all Norway residents who are sixth born or later in their families is lower than the country mean of 5.2? So we are interested to see whether mu is less than 5.2, which means our null hypothesis will be greater than or equal to 5.2. Again, notice that this is one-sided. But now we're going in the other direction. In the last problem, this was a greater than, but now it's a less than. Okay, 2, test, statistic. Okay, so t-stat, which has the same formula as before, x bar minus mu naught over s over root n. Let's plug in. So our x bar was 4.7 minus mu naught, 5.2, divided by s, 1.8 over root n, so square root of 581. So I get a negative 0.5 divided by 0.075, and I get a value of negative 6.67. Okay, rejection region. Recall the rejection region follows from the alternative hypothesis. So note that this is a less than, which means our rejection region will be a less than. So we will have t-stat less than negative t, and minus 1 will be 580, comma, alpha 0.01. So if we look that value up in our table, so that would be t-stat less than negative 2.3263. Okay, so let me just reiterate, because this was a less than in the alternative hypothesis, we're using less than here. And if this is less than, then this is negative. So in the last problem, this was greater than, and so it was greater than a positive, but now it's less than a negative. Okay, and in terms of degrees of freedom, so 580 is not on our table, but because it's such a big number, we can just go all the way to the bottom and use whatever the max number is, which is 120, and I actually went beyond that. I just used the infinity line, which is the bottom row in the table. So that's, but the difference in values is very tiny. Okay. 4, conclusion. So we plug our test statistic into our rejection region. So we have t-stat is equal to negative 6.67, which is less than negative 2.3263, which is our t-stat. So this is indeed true. Negative 6.67 is indeed less than negative 2.3263, which means our t-stat is in the rejection region, right? Our t-stat is less than our critical value. Therefore, we reject the null hypothesis. So therefore, we reject H naught and accept HA. Okay, so unfortunately, we do reject the null hypothesis here. So what we're going to say is there is enough evidence to conclude that the sixth born child from Norway has a lower IQ than 5.2 at the alpha equals 0.01 level of significance. Okay, so this was the critical value approach. So now let's do the p-value approach. So we know steps 1 and 2 are the same as before. So if I want, I can just recopy them down here. And again, we don't do both methods usually. I'm just doing both methods here so that we can get more practice. Okay, so step 3 is where things are different. So we calculate the p-value, which is the probability that T580, again, I'm using the infinity line, not 580, is greater than the absolute value of T-stat. So that would be P T580 bigger than 6.67. Now, again, this is a really big number. You can't find 6.67 on the table. So that means we can just assume that this is highly significant, so 0.001. So when we form our conclusion, and actually, if I can draw a picture real quick. Okay, sorry, this is so ugly, but if we had 6.67, this area right here is 0.001. So conclusion, we just compare p-value with alpha. So our p-value is equal to 0.001, which is less than 0.01, which is our alpha. So when p-value is less than alpha, thus reject H naught, accept HA, which agrees with our critical value approach, which is what we expect, and then interpretation is going to be the same. So let me just copy it down real quick. So we would have the same interpretation. Okay, and those were two examples of hypothesis testing for the mean.